Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is maximum difference between node and ancestor, and it is a medium level problem. So the problem basically says that we have been given a binary tree and we have been given the root of that particular binary tree. Now we have to find the maximum value of the absolute difference between a dot val and b dot val, right? Where let's say one of them is the parent and one of them is the children. Now it does not have to be a direct parent child relationship. For example, this particular 8 can have the absolute difference with this particular one because it is one of the children of 8, right? This is what they're trying to say. So we have to find the maximum value of the absolute difference between two values where one of the item is the parent and one of them is child. So 8 and 1 is also possible because this is the ancestor and this is the child, right? So basically all the elements in the subtree of 8 are valid to be taken as the difference, right? This is what I wanted to say. Now whenever you have a range of values, let's say, and you have another value x, you want to find any value from this particular range which will give you the maximum absolute difference, right? So x minus y, let's say y is some value from this particular range. Since I have a subtree, it will have some values, right? So I will obviously get a range of values, right? So if I'm talking about this particular node, let's say this particular node has value x. If I consider all of these values, there will be a range of values. That means there will be different values. Let's say this is minimum value among them, this is the maximum value among them, right? And now I want to select a value y from this particular range such that x minus y modulo or this particular absolute value is maximized. So there are actually multiple possibilities. X might lie here, x might lie here somewhere in between, and x might lie here somewhere in between this one, right? So you see, there is no actual benefit of taking some point from between in this particular range as y. Either y will be equals to min or y will be equals to max. These are the only two possible values which can give me the best answer. So let's say how is this true? So if I talk about x from here, let's say this is x1, the maximum value of absolute difference will be when this particular distance is considered, right? This is true. When I talk about x2 from somewhere from between, so I might have two distances, either it will be this one or it will be this one. One of them will be greater. So if I take any distance in between, it will always be smaller, right? So either it has to be distance from min or it has to be distance from max, right? Again, if I talk about x3, which is here, obviously you can clearly see that this distance is maximum, right? This is the only possible answer, right? So in all of the cases, either minimum from the subtree will give you the maximum or the maximum from the subtree will give you the maximum. The problem reduces to, for each node, first of all you will have to find the minimum and the maximum value inside its subtree excluding the current node, right? So for each node I have to find the minimum and maximum in subtree, first of all excluding the current node, and then take its answer with minimum and then with maximum, right? So this is how you can calculate your answer. And when you return, let's say this is the particular node, I have found out the minimum and the maximum in this particular range. Then when I return, I also have to include this particular node as well. Where do I return? This particular subtree will return the maximum and the minimum of this whole range including the element itself to its parent, right? So this is how simple the problem is. Not very difficult. You just have to calculate the minimum and the maximum in the ranges. So I believe it would be much better if I just show you the code. So what I've done is I've initialized my answer with 0. I've taken an infinity value to be 10 to the power 6 because the maximum node values here is only up to 10 to the power 5. Right. So now what I do, I initialize my DFS from the root node, and if the root is equals to null pointer, I'm just going to return the minimum and the maximum value. So you see, minimum is initialized at infinity and maximum is initialized at minus infinity. Each node is going to return a pair where the first value is the minimum and the second value is the maximum inside that particular subtree. So I get the left information. That means I get the information what is the minimum and the maximum in the left subtree. Similarly, I get the information what is the minimum and the maximum in the right subtree for the current node. So I update my min as minimum of left dot first and right dot first. So basically I am taking the minimum from both the subtrees. Similarly, I update the maximum as left dot second, right dot second. I am taking the maximum from both the subtrees. Now if either one of them is not null pointer, that means this is not a leaf node, because if there is a leaf node, there will be no children. and it cannot have an answer. So if it has either one of the children, that means node dot left is not null pointer or node dot right is not null pointer. I'm going to update my answer as my current answer. So I'm taking the maximum of my current answer, then the absolute value from minimum minus node dot value, and the absolute value from maximum minus node dot value. So it should be either one of these cases, that from the current node value, it should either have the maximum distance from the minimum value or the maximum distance from the maximum value inside its subtree. Now when I return this the minimum and the maximum of this particular subtree, I also have to include the current node. So for the minimum, I take the minimum of the current minimum and the node value, and for the maximum, I take the maximum of current maximum and node value, and then at the end I can just return my answer value. This would be my final solution. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see, it passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.